been on day 4 for the climate change and organization. In the past sessions, we've gone through multiple discussions on local and global climate change scenarios with hands-on workshops. Sessions were conducted by expert Professor Rafiq Ham, local faculty expert Dr. Subhi Mehrotra, academicians Professor Subhi Ghosh and Dr. Vikunya, and practitioner Dr. Today, we are seeing for lecture from Professor Hamdi on adaptation and mitigation strategy, followed by Dr. Mehrotra on local climate zone classification system for identifying microclimate at urban scale, and Mr. Saranj Bajpai on assessing the mitigation potential of urban areas in India. With this, I would now address Professor.
Thank you very much for the introduction and good morning, everyone. So as it has been introduced, I will talk about the adaptation and the main adaptation and mitigation using solar power. I will give you an example. Can you change the slide? You will do the okay. So next slide, please. So first, as I said, there has been some slides that I did not discuss with you, and so I will start first by taking what is this information from the latest report. So we will start by this, and then we will go to have some practical questions to how to do the mitigation and the adaptation. So first, I extracted the information of, you remember, in the lecture of the third lecture, I show you what has been the information from the latest report from working group 1, 2, 3, that we focus mainly on the, how the urban island will change in the future, and etc. But here, I extracted the information on adaptation and mitigation first. Next slide. Okay. So, what has been deduced from this latest report, and this is the latest report, is that the urban adaptation option will reduce the risk, but it is unusually and inadequate. And there are limits to adaptation in and around urban areas, particularly as warming increase. What does mean this? This means that if there is any delay in concerted global action on urban adaptation, we will miss the rapidly closing window to secure a livable future for all. What does it mean? It means that the report said that for urban area, we can adapt. But we need to act now. If we don't act now, this window here, the window on which we can adapt our cities, will be closing. Why? Because with warming, having more and more warming in the future, this window where our action can be effective will be reduced. So if we make any delay, this window will be reduced, and the action and the mitigation action that we will do, it will not have a big effect. For example, in Brussels, what we do, we try to see what impact of green roof and impact of white roof, for example. If we have green roof and white roof, what we found is that this mitigation action is beneficial, but only in the near future. It was around 2040. To reduce urban heat island in city is good. But then when you go to far future, this mitigation option was not enough, because the warming is that big that even your adaptation that you will do will not have any beneficial effect. So that's why this is what the report says, that you need to do the urban adaptation, you need to do it now. You need to have action now for your city. If not, these windows on which you can have still some efficacy, it will close. So the urban and infrastructure system transition can be accelerated by implementing feasible adaptation options option and bringing its strong synergy with mitigation. So we need to think of adaptation, of action that benefit for both adaptation and mitigation. And I will give you, for example, one. This has been the work of my colleague and my friend Ansar Khan from Kolkata University. We work on if we put solar panel cities. So solar panel, okay, we will reduce the CO2 emission, right? So we will not, so we will use renewable energy for solar, using solar panel. But if solar panel can impact the urban climate, the local urban climate, this was the question. And I will show you that it impacts, in fact, the urban climate. So this was a recent paper in Nature Cities. So, but we need to think, always we need to think of action that can affect both adaptation and mitigation, if possible. So urban and regional planning that promote compact urbanization and protect ecosystems. So from this report, we say that it's better to go for compact city in the future. Because compact city, if you have compact city, you can say that compact city, you will have more heat island because it's compact city. So maybe but the problem is that you need to think in a systemic way. Because if it's compact, you will reduce CO2 emission. Because if your city is compact, you will reduce the transport emission, you will reduce a lot of things. So you need to think of for different sectors, not only for one sector. So you need to think in systemic way. So this is what has been said in the report, is that we need to think of the urban system. It's very difficult, I know. You need to take different sectors into account in order to see how you would like to build your city. And we will have some concrete questions that we will have. So, upgrading informal settlement by investing in accessible climate resilient infrastructure and locally relevant ecosystem-based adaptation option and nature-based solution. So we need to think of using nature-based solutions in cities. For example, the greening of cities, we need to think of the species, of the plant species that you would like to put in your city. And you need also to think of, do you need irrigation for this? So it depends on your cities. Are you in an arid? So if you put vegetation green in the roof, and there is not enough water, it will die. So you need to think of, do I need irrigation for this? So maybe I need to use some species which are local species, so which are already adapted. So all these questions you need to think of this. But we need to use this nature-based solution option. Social infrastructure and services such as health, education, social safety net, and climate services, and also for disaster management. So we need to take all this into account. So I just talked about greening. So the climate change battle will be won or lost in cities. And from this report, we know that feasible and effective adaptation and mitigation options exist. So you go to the market, we have these options, and they are being implemented, but we need to accelerate the action and target particular vulnerable places and people such as the slum, for example, and invest in hybrid solutions with multiple co-benefits. So for example, you think of, okay, I will put some green roofs or more vegetation, but you need to think of pollution. Is this vegetation that I am adding to the city, is it affecting the pollution? Maybe it will increase the pollution or it will increase the allergy. You have some people who are allergic to some type of species in cities. So you need to think, I told you, in systemic way. Okay? So, I was just talking about the growing of the city. So we have the trade-off. We need to think of trade-off between mitigation and adaptation, and this needs to be balanced. So there is, as I told you, we need to think both mitigation, adaptation, and always there is a compromise. There is a trade-off that we need to take into account. So maybe increasing urban density can reduce the travel demand, as I told you. So if your city is compact, the travel will be decreased, and hence the emission. But you increase the vulnerability to heat wave and flooding, of course. So you will reduce the CO2 from the transport, but if your city is compact, then your heat island will be big. It will increase the heat island, and if you have a heat wave, of course, and if you have a flooding, it will affect a lot because your city is concentrated, right? So urban electrification powered by hydropower, biofuel, and nuclear sources can impact aquatic, coastal, and marine ecosystem. And I just give you the example of using solar panel. You can put solar panel. I will give you an example on Kolkata. We simulate this. You will see that it impacts the city also. So you need to think in a systemic way. So climate resilient development combines climate adaptation strategy, mitigation action, and pathways to support the sustainable development for everyone. What is saying this? It means that when we are making this action for mitigation adaptation, and I know tomorrow you will have this exercise with Professor Suraki of making this to think, so you will work by group to work on this, to talk and to see how you could adapt your city. There is always the fact that yes, here, a pathway to support sustainable for everyone. You need to think for everyone. So no one should be left behind. So you need to think of, and particularly for the vulnerable people. So this you should not forget, and no one should be left behind. What he's saying here is that current climate adaptation is often short-term and associated with specific project or discrete action. But adaptation expands into climate resilient development when it connects to sustainable development and mitigation. Takes a longer time horizon and involves multiple stakeholders to accelerate transformational change. What is the saying is that, for example, we are very used, all of us, to check the weather, right? If you would like to go this weekend or somewhere, I will check the weather and I will see what. The stakeholder should, and also us, we should think in the same way, but not on weather for 3 days, but for climate, for 30 years, for 40 years. The stakeholder should take this information for the adaptation, and but it's difficult because it's not, you are not planning for tomorrow or this weekend, you are planning for 30 years. So it's a bit more complicated, but it's the same concept. We should take into account the adaptation, but usually think of long time. So not only the short, because usually adaptation is for short projects. I will try to put vegetation, but it's only related to one project, but it's short in time. Think always and involve stakeholders. We talk about the stakeholders, involve multiple stakeholders. You need at least for the city, the city, different sectors. So don't focus on one. At least have 2, 3 stakeholders in the city, because then you have at least 3 points of view that you need to take into account in the city. It's multiple sectors. So think always of systemic way in the city. Systemic. So the city are key to climate action, and the climate change budget will be one. So I already said, and I think that yes, we need to accelerate action, target particular vulnerable places and people, and invest in hybrid solutions with multiple coping. I already said this. So now I will give you some concrete questions that you need to ask when you are trying to do climate urban adaptation and mitigation. So here, these are the people with whom I am working. Here, so I'm working with Ansar from Kolkata, so the university, Kolkata University. We are working also with Professor Dev from University of Texas, and with all these people here, and also with he's very famous in adaptation and mitigation of cities, mainly adaptation using full roofs. So we are working with this network to try to work on global cities, not only focus on Europe or India, but really try to focus on global aspects. So this is our team. And yes, now I will go with you and try to see some concrete questions that you would like. And I think this will help you for tomorrow. We will have this workshop with Professor Surapi of you will work together. These are the questions that you will need to address. So why are you trying to cool your city? This is the first question. And this is these are associated questions that we should ask to make the mitigation plan. So first, why I am trying to cool? I should answer to this question first. So is it because this is the things that everyone is doing? Or Because, for example, if you look to most cities in US and Europe, they are in cold climate. Where, for example, the heating degree day, you know the heating degree day, and of course, you know, and the cooling degree day, and so the heating degree day is much more bigger than the cooling degree day. Okay? And cold fatality are much more higher than heat fatality. Yes, I mean, if you are in a colder winter, I give you this example. I give you this example yesterday. I think, so this is in the city of Ghent. You see that in the rural area, we have much more freezing than in the urban area. So the urban is warm, so we have less problem with freezing in the city. So you need to think. So, and I also show you this problem of for the buildings that this ice crystallization is much more problem in rural building than in urban building. You see, in urban we don't have any problem of this crystallization of building. So for us, urban demand is good during the winter. So you actually can have many winter time benefits. So you need to think always winter, summer. So you need to think this question. So still, maybe the urban heat island is not your friend. In fact, I based this presentation from one lecture that I got from Professor Elie Bouzet from Princeton University, and it really inspired me a lot. So it's mainly based on his presentation. So what is first thing to ask? What is your climate plan? First question. Is your projected hazard going to significantly shift from cold to heat with climate change? Look at extremes, not at average. We need to see the extreme, how the extreme will change, not the average. The extreme will impact the city much more. If you have flooding, if you have heat wave, so think of the extreme and think, what will add climate change to my city? And for this, as I told you, it will be difficult to get this information from global climate models. You need to do downscaling. Global climate model will not see Bhopal. You need to do downscaling. You need to go to higher and higher resolution to see how my climate will change in Bhopal. And from this, so I need to answer this question. So I need to compare summertime and wintertime urban heat island. Which is the strongest? Here I know that, for example, in Bhopal we have a cold island because of the lake. So, and this it will very much depend on the annual cycle of rainfall and radiation. Of course, if you have, for example, different background climate, the urban heat island is different in winter and in summer, depending on the background climate, depending on how much of precipitation and how much of temperature. And this is very, very important. And Professor Ansar just remembered me this yesterday. He told me we need not to focus a lot on urban heat island, like the difference between urban and rural. We need to consider urban temperature only because how the climate change is affecting, because the cities are more related, or the urban area are more related to sensible heat, because the latent is not that important in urban area. So in urban area you have the sensible heat, but in the rural area you have the latent heat. So it's different process. So it's good to think of the urban heat island, but you should also think, when you are doing adaptation, mitigation, to the absolute urban temperature. You need to see how your temperature in the city will increase, independent of the rural. I told you, yes?
So, firstly, can you just explain sensible heat and latent heat in terms of how it plays a role in urban temperature and rural temperature?
Yes, thank you. Because maybe I pass very fast on this. So the sensible heat is how much of exchange. So you need to think of heat, of temperature. So the sensible heat is related to the temperature, to the heat. So it's the amount of heat which is exchanged from the surface to the atmosphere. And the latent is the amount of moisture. So it's related to the moisture, to the humidity. So the sensible is to the heat, and then the latent is related to the moisture, the exchange of moisture between the surface and the atmosphere. So it's different thing. Why the sensible is more important in city? Because in the city you don't have a lot of moisture. So it's more heat which is exchanged. While in the rural area it's the other way. So I have some lecture, but maybe tomorrow I can. So to show you that the energy balance is completely different. That's why I showed you this yesterday from your question. The energy balance is completely different in urban and in rural. In urban, all the net energy that you get, the net radiation, the energy you get from the sun, so the net radiation is mainly used for sensitive. While in the rural area, the main energy that the surface gets is used for latent, there are other fluxes, but these are the main difference. So that's why it's good to think of urban heat island to reduce this, but it's also, don't forget to consider only the urban temperature. It's very important because I told you yesterday, the climate change in my city, in Brussels, in fact, in the future, the urban heat island decreased. I told you this yesterday, decreased because the rural area warmed a little bit more. Not that much, it was 0.25 degrees, so it's not a lot. But don't think of urban heat island because you can be misleading. Because urban heat island it will be decreasing in the future with climate change. But this will not affect anything. In fact, we still saw that the heat wave will impact the city much more than the rural area. So don't think always on trying to reduce the urban heat island. Think also of the absolute temperature.
I have another question. You're talking about a compact city. On a city level, right? The concerns are basically city level that the more you spread, the more anthropogenic activities increases, transportation increases.
Yes.
But compactity is good where in our country where we have more cooling degree days.
Yes.
But in heating degree days, which is more prevalent in temperate climate, it will affect one major thing, that is individual level solar access.
Yes.
When I was reading about it, solar access, at certain areas, you need to have solar access till certain time of the day. Individual units,
Yes.
architectural units, you
Yes.
need to have solar access according to the law.
Yes. Yes.
But
Yes.
in a compact city,
It will be difficult.
it will be
Yes.
difficult, and that will increase the heating requirement of individual units.
Yes. Yes.
So,
it's
both
a
that
compromise.
have,
It's a compromise. You need
so
to
which is going to have a worse effect, because energy consumption in this case for heating will increase, but we will decrease in anthropogenic activities.
Yes. Well, I cannot answer like in one answer. It depends on the place. It depends on the situation. You need to, but it's a compromise. It's a compromise. You need to do work and to see. Yes, for my city, for example, what is the most efficient? Is it to have a sprawl, maybe, or is it to have compact and to see with this law? You have this law that to get the solar radiation. So it depends on the city and on the climate. And I cannot give you one answer that you need to go this direction and not this direction. It will depend on the.
It also depends upon the behavior and social context.
Exactly, behavior, yeah, definitely.
People are
Yes.
drying their clothes on terraces, they need individual units and they need that sunshine, daylight. And that is behavior aspect
Exactly.
which also should be considered. If
Yes.
you have, people would like to live in apartments, then the things will be totally different. Then again, last time also we discussed about sky view factor, how much
Yes.
openness.
Yes.
So that is also related with how much radiation we want
Sure.
and how much wind flow we want in an area. So it is always like it has to be variable and
Yes.
cannot be fixed.
Yes. Okay. So don't focus only on the difference. Consider also the absolute urban temperature and how it evolved in the future. So another question, is heating or cooling more expensive and carbon intensive in my city? So yeah, here I don't see the heating. You don't have problem with heating. So yes. Can you implement summertime heat mitigation that does not reduce wintertime urban heat islands? Another question also that one can ask. So another things, once you answer this first question, another things that you need to answer, which urban heat island exactly I am trying to mitigate? Which one? Because you have different one. So which one is it? So if I took Bhopal, so this is the surface urban heat island, okay? So we have a cold island from the paper of Professor and we found that there is a cold island. So you can consider urban temperature and their difference relative to rural temperature, at the surface, like this paper. But you can consider in the air at 2 meter level, or at higher elevation. Maybe you are interested by higher elevation, also at 50 meter or 100 meter. So, or beneath the surface, you have also impact on the urban, or the difference beneath the surface, because in the underground, there is a difference between the city and the surrounding. Or in your water body, and this is very important and very typically for the city of Bhopal, you have a lake, you have a big lake here. So you have also problem of you can have this, what we call hydrological urban heat island, in the sense that the water, during, if you have precipitation and you have surface runoff, okay, this water, it will run off on hot surface and then it will go to the lake. So it will, the surface, the temperature of the water will be higher because it is runoff on warm surfaces. While in the rural area, this is cold, this is so it's not hot surface. So you can have a difference in the temperature of the water between the city and the surrounding. And this is very typical here for Bhopal because you have a lot of lakes, so you need to think of this. So how the urban area surrounding the lakes can affect the temperature of the water of the lake. So it can affect also the quality. So all this should be, so there is different urban heat islands. First thing to, which one I would like to mitigate, okay? So, and also, so if you think of surface urban heat island, it's a much more larger in magnitude and vary drastically in space. And is almost invariably stronger during daytime when solar insolation creates big difference in it. What does mean this? Means that the surface urban heat island, usually we use satellite to study this, the big difference is during the day, not during the night.
Yeah.
And the one thing is that if you look to the surface urban is very drastic, it changes a lot in space. Look here for Bhopal, you have, it's very heterogeneous, the surface. But if you look to the urban heat island at air temperature, it's much more homogeneous. It's not all homogeneous, it's not flat the same, but it's not as drastic as the surface. So it's different. So this was for New York. Okay, another is that, yes, this is what I just said. Air urban heat island is smaller, much more homogeneous, okay, than surface urban heat island, and mostly peaks during the night when the urban surface are releasing the stored heat during the day. So surface urban heat island peak during the day, while air, we call it air, but 2 meters, atmospheric urban heat island, it peaks during the night. So it's different peaks. So it's not the same peaks. So they have different impact. Air, urban heat island, usually the most important for cooling demand. So if you are, for the cooling, if you are in the heat, in hot climate, it's mostly the air urban heat island, which is the most important for you because it will impact the cooling. It's not the surface. You don't care about the surface. Okay? So, and also your aquatic system and water quality will be most directly sensitive to your hydrological urban heat island. Very important for Bhopal. So you need to take into account this. And yes, I already showed you this. The fact that during lockdown, when we stop the cars, the air temperature, the urban heat island decrease in late afternoon. So here it's the urban heat island. It's the air urban heat island. Okay? So, because, this is I already said that hot urban pavement generate warm runoff that make urban streams warmer than their rural counterpart, on average and at maximum. You can look to this paper. And as implication, as with the atmospheric urban heat island, cities create a hydrological urban heat island. So I already explained this. That and you need to mitigate also this impact, because especially for Bhopal, a lot of lakes. So think of this. So another question, where in the city are you aiming to reduce temperature? So which part are you interested? So are you interested in this part, or the part where you have a lot of slab, for example, or you need to think which part of the city I am targeting, okay? So do you want to have an average cooling of 1 degree over the whole city? Are you interested by the whole city? Or is your overheating problem mainly in the urban core, in the old city, for example, maybe? So it might be an industrial area with a lot of dark roof and parking, not away from the core. So it depends, where are you, which part of the city are you targeting? So how variable is the urban heat island in your city? For this, you need to look to satellite data. So is it homogeneous in my city? Is it one part is really very hot spot, and the other part are okay? You need to know. You need to have a spatial information on your city. Where is the problem in my city? Okay, so is it strongest in poorer neighborhood that have little tree cover, like slums, for example? You don't have a lot of trees. So is it strongest in this area or not? We don't know. You need to investigate this. Can we use urban heat island mitigation as a tool for increasing environmental equity? It's a question for inclusiveness. Huh? I told you, no one should be left behind if you would like to do a good adaptation measure. So where are pedestrians most concentrated? Do you want to target this area of pedestrian? Are some area near large water body, which is the case here for OPA? So the lake, the lake breeze, lake land, not lake sea, it's lake land, sorry. Breeze means that they are better off during the day, but maybe worse during the night. So you think you have a lake here, so you will have what we call lake breeze during the day. It's a lake breeze, it's a video I am still trying to make the runs, but it's still not working. So I can show you that when you have a lake, you will have some wind which goes from the lake to the surrounding, because, okay, during the day, so it's a breeze. It's like I told you this. So this might impact the surrounding of the, so you need to think of this also, okay? So where are the surface or area you can intervene in? Because there is maybe some place where you can have intervene, you can make action, but maybe some place you cannot. So you need to see which part also that on which you can intervene. Okay? So it means it's still possible to do actions. For example, in Europe, we focus more on suburban area. Why? Why? Because suburban is still developing. But why in the pure dense we don't have place to do any action? So you need to see where in my city I still have possibility to make action. So now I will show you some tests that we did for Kolkata with Professor Ansar. So it's paper published 2023. So what we did, so is we try to see different options. So here we use cool materials. Okay, for Kolkata, so this picture. Then we try the green roofs, the vegetation fraction change. We increase the vegetation, and then D is a cool city and super cool broadband material. I am not expert on this, but Ansar is expert on using this material here, and you can see here how it can. So this is the difference of ambient. So it's 2 meter temperature. It's the air temperature. How the air temperature can be reduced, you see, until -2 here in the center of Kolkata city. And this is how it affects the surface temperature, not the air. You see that the surface you can get much more higher, -4. While the ambient temperature is only -2. So yeah. So and then you can see, okay, if I consider that I can put action on all the city, this is what we'll be doing. Okay.
Sir, what does mean A and T, cool material and super cool problem?
I think that cool, yes, this and this one. I think it's a difference in the albedo of the roofs. And you are using some material which have a really high reflectance. So the albedo is mainly about the albedo of this material. I think they are using nano material, something like this, which have a high albedo, a high reflectance. Why? This cool material is like the material that are already in the market that you can use it. But this is like a new super. I am not expert on this too, but these are some really super. Yes. Okay. So another picture here is that, but yes, of course, you need first to check if your model or if your observation is good. So here, this is the urban heat island of Kolkata from observation. So this red here is the mean observation, mean urban heat island. You see, that's why I asked you yesterday for the tutorial to try to plot this, because this is the normal shape of urban heat island. During the night, it should be high and then decrease. And then again high during the night. And so that's why I asked you yesterday to make this, to try to reproduce this shape. But you see in Kolkata is that this is 0. During the day it's negative. So it's a negative urban heat island during the day. So it's different. So you need to take this into account also. While in Brussels, for example, the urban heat island during the day is a little bit higher than 0. It's very weak, but it's not negative. So different things need to be taken. So the urban heat island, yes, the urban heat island, always in this paper of Ansari 2023, we found that this is the sea breeze. So you have here the sea, and then you have Kolkata here, and then you can see that this, if you put this mitigation, if you put roof, it can impact also how the sea breeze is penetrating into Kolkata. So it's not, so you see that it's not only, it will not impact only the temperature, but it will impact also the local circulation. Like sea breeze here in Kolkata, it is impacted by this mitigation that we are doing. The same here. Here you have also local circulation from the lake. So you can see, for example, if you put any mitigation option for the Bhopal, how the lake breeze can be affected by the mitigation, this mitigation option. So another question that we need to ask: when time of the day, period, do you want maximum cooling? Which time of the day you are targeting to have maximum of the cooling? Because as I told you, surface and air, urban heat island, they have different diurnal cycles. The surface peaks during the day and air often at night. Which one are you targeting? So which one? Do you want to make the whole summer more pleasant, or do you want to focus on heat wave period? That's also very interesting. In my country, the urban heat island during the summer is okay. We don't care. It's good. During the winter, it's even beneficial. But the problem of urban heat island in my country is during the heat wave. Because during the heat wave, the old people and the people who are vulnerable, during heat wave, and if you are in a city, during heat wave, the heat stress will be much more in city than in the surrounding. So we don't care about summer, normal summer. We care only during the heat wave, because this is where the people are, the mortality and the morbidity and hospital, going to hospital, people going to hospital is increasing. So we need to have this question: which one are you focusing on? Is it the mean or is it the extreme? And don't expect consistent results from your mitigation measure every day. The effectiveness of mitigation measure depends on cloudiness, wind, time of the day, antecedent soil moisture, etc. I will give you an example. So you will say, okay, I will put white roof to mitigate my city, but is the white will be still white? It's not sure. Because with all the aerosols and all the dust that will be on it, it will be brown. It will not stay white. So you need to have to maintain this. So it's, well, another thing is, can you use irrigation during extreme heat? Can you increase irrigation? So you can think of, okay, during extreme, I can increase the irrigation. If I increase the irrigation, the plant will evaporate more. Evapotranspirate. So the plant will transpirate more, and then I will get cooling. But is this correct for your plant during the extreme? Maybe your plant, when it is extreme, they will close the stomata. They will not evaporate. You have some plants which close the stomata, their stomata during the extreme. So you need to think: is it good for me if I increase the irrigation? Maybe it does not. It will not add value to your. Because you will not get more cooling because your plant is stopping the stomata, no transpiration. Okay? So, and yeah, this is just to tell you that this is the urban population. I was talking about the people. So here, this is the urban population which are at risk of extreme heat, and this is today, and this is in the future, 2050. So this is from where we got this data. And you can see that if you look here to India, you can see that a lot of people will have this risk of extreme. So you need to focus on extreme heat for all these people. You see that, for example, in over 1.6 billion people will suffer from this. They will be at risk of extreme. So I told you about the future. This is just to show you we need to have information on the future. Okay, and yesterday and the previous lecture, I told you we need to know how the climate change will change in Bhopal, for example, but we need to know what is the uncertainty. Do I need to use different projection or only one? Or this is what we did here. So in this paper, in Communication, Earth and Environment, what we did is that what they did, it's not me, what they did is that they try to see when you have compound, drought, and heat wave. Okay, so we are concentrating or we are interested by a compound. I told you what is compound. So compound is you have drought and you have on top of it heat waves. And then if you focus on India here, you can see that if you are interested by this extreme, what is the most important is, so if this is like the uncertainty, is the uncertainty coming from the global climate model, or is it from the scenario? I explain the scenario, different scenario, or is it from the indicator? You can have different indicators for a drought. You can have from the soil moisture, you can have from the hydrological, you can have from the precipitation. So which one are you using? But we use different indicators. They use, not me, but they found that the most important, you see here, 53% is coming from the global climate. What does mean this? Means that in India, if you are interested by this compound extreme, it's better to take as much as possible different global climate models and not scenario or so. Whatever the indicator you will take, it's only 24, is okay. Or whatever one you will take, the big uncertainty is coming from the global climate model. So it's better to use different to study your city using different global climate model, because this is the uncertainty, the big uncertainty in the region of India. Okay, so and it's changing. For example, look here to Mediterranean. You remember I told you in the previous lecture, the Mediterranean basin will suffer a lot. It's hotspot for climate change because it will be more heat, yes, and less precipitation, more drought. You see that in Mediterranean, what is the most important? So we don't care about the GCM, it's the scenario. So it means that whatever global climate model you use, it will give the same projection. So don't worry about using different global climate model. If you can use only one, is enough. The most important is the scenario that will affect this region. But in India, it's not the scenario. Okay? It's mainly the uncertainty is from the global climate. That's also interesting to take into account when you are doing mitigation, because you need to see in the future your action, is it still okay also in the future plan. So this, okay, then what is the timeline over which you want results before? Yeah, this is just because you know that the election, the stakeholders, they are thinking always of the election. So it's always for 5 years or so. So they are not taking off longer action. So we need to think. How quickly can you get approval and actually implement the mitigation plan? So, because sometimes you have bureaucracy, you have administration, it takes time. And what is the climate change timeline of your city also, which means on which timeline you are analyzing? Okay, so, yes, another question, what urban solutions are most effective in my city? So this depends on geoclimate, trees and tall vegetation. Should I use short vegetation? Evaporation cooling without vegetation. So depend on which species I need to use. Is it reflective surface, the most important? Is it reducing most heat? The material that store less heat? Which one I need to use for my city? And maybe co-benefits. Maybe I need to use 2 or 3 of them. And also the species. Which species I need to take? I was just in one project last week in Belgium, and this project we try to see is the species in the urban are different. So we take the same species and we put it in the urban environment, and we take the same species and we put it in rural environment. And they make a comparison of these species between the two environments. We found that the same species, but if you put it in an urban environment, it has less stomata. So it's an adaptation of the species in an urban environment, that the same species have less stomata, so it will evaporate less. So you need to take this into account when you are doing adaptation. So here are a different way of doing this adaptation. So you have the baseline scenario. So okay, maybe I don't care. I don't care. I don't need any adaptation for my city. Maybe you need green roofs. Maybe you need novel material, as the paper we did with Ansar using this super cool material. Maybe retroflective facade, smart irrigation also. So to think how I can increase the irrigation during heat waves. Then it will cool, but maybe it will not be effective use. So you need to think of this. So another paper here also by the team of Professor Han was to see, this is the super cool material that we use here, okay, for, and then what we found is that it works for one climate, background climate, but it's not working for another background. So here you see that optimal cooling of dry condition with clear sky in Iran. So this type of super cool material, it is working only in dry condition, okay? Because it's in Riyadh, in Saudi Arabia, it's very dry, so this is dry condition and clear sky. So if you have this type of material, it will work only in clear sky condition, dry. But it's not working very good in Kolkata. Why? Because Kolkata, you have a lot of water vapor. And this water vapor, what will do, it will reflect. So you have this radiation which are reflected, but if you put the water vapor, you remember from the lecture I told you in the beginning, water vapor, they will reflect this. They will reflect. So the radiation will come back. So we will not be able to reduce. So it depends on the background. So you need to take this into account. And this is the paper, the last paper with Professor Ansar that we did and published in Nature Cities. What we wanted to know, I told you we need to combine between mitigation and adaptation. We try to, we said we will put solar panel on Kolkata. Okay, we put solar panel on all Kolkata, and we wanted to know if we put this, because it's good for the emission, right? So we will decrease the emission, etc. But is this solar panel impacting the urban climate of Kolkata? But we found that it's yes. We found is that photovoltaic solar panel warm up and cool down city. So it will warm up during the day. During the day, we found that it warmed up to, you can see here, up to 1.5 degrees the city of Kolkata. But during the night, during the night time, it reduced by 0.6. I will not enter into the process, but just to tell you that using solar panel over one city will not, it will affect also the local climate. Okay?
Sir, it is affect only for the day.
Both day and night.
It will affect it will increase the temperature
In the day.
into day.
Yes, in the day increase by 1.5 Celsius, the air temperature. Yes. But during the night, it decreases a bit by 0.6.
It is not absorbing the roof area. That's why.
No, in fact, what we found is that when you put this solar panel on the roof, the solar panel, they are not, if you have the roof, the solar panel are not like this. The solar panel are always like this.
Yeah.
Okay? And if you have your solar panel like this, you have some air which can go inside. This air which go inside, it gets warm.
Yeah.
Because these surface are warm. You know, the solar panel can go to 70 degrees or more, I think.
Yeah.
So this air warm and then go and for all, and then go up, and this warm during the day to all area. And this is quite new because it's very because before people that study solar panel did not take into account this effect.
Okay.
But this was the first time Professor Ansar and his team, we take into account this effect that you have air which can go inside and which can affect, and so it's the sensible heat again.
Yeah.
I told you in the city, the sensible heat is very important. You should take into account. So that's why we're very happy that it was accepted in Nature. It was in November. Okay, so this is the type of, and then I will finish in.
Okay. Yeah, one.
Sorry.
How much is the area of impact? The warming of the air
Yes.
around the solar panel.
Yes.
How much is the area of impact around the panel?
We consider here that we put all in the city. 100, all the roofs are with the city. So it's over all the city. So this means it's
That
over.
is a case scenario that we
Yes, it's a case scenario. It's not observation. It's a case scenario with WRF. We use WRF, you know, this WRF. WRF is atmospheric one. And we just consider that we put roofs on all the city. Of course, it's not possible because you have some roofs which are like this, but you have other roofs like this. So it's not possible to put all. But it's a simulation. That's to say that we need to take into account that if you put solar panel, you might increase the temperature in your city. But it's a simulation.
One assumption that you have taken is that all roofs have
Yes.
solar panel.
Yes.
There
Yes.
could be another assumptions, many other assumptions also, like the height of the buildings are really
You are right.
same.
Yes.
If there are high rise, then they
Definitely.
have shading
Definitely.
effect.
So we took different heights depending on different local climate zones, because different local climate zones have different building heights. But of course, we did not go into the details, like changing the height every one, and we did not take. So it's a simulation where we consider that we can put this on all places.
And also the trees.
The trees, of course, yes.
The
yes.
high
It can also
canopy and other shading.
Definitely, yeah, the shading.
Because, sir, was this simulated for a particular month? For a particular month?
This was during the summer days.
Okay, so in summers it will have a 0.5 degree increase.
Yes.
And can we understand what is the impact of this during the winters?
What is the impact?
The same scenario.
Yeah.
In winter, how will it impact?
Winter, no, yeah, we did not make this during the winter, yes. Yes, but it's good, yeah, to see, to answer. Just to tell you, just to give you one example of, we try to combine adaptation and mitigation in the city, but you can have increase of temperature in the city. So if you don't do it, so here, the recommendation was that we need to use solar panels which can decrease the heat which is going out. So we call it the efficiency of the solar panel. So it is because solar panel, they will use energy. So the solar radiation, one part will go to electricity, but another part it will heat the surface, and this part will go to the air. So if we decrease this part, that's good. This was the recommendation. We are not saying that solar panel is not good. Of course it's good, but we just think of, it will affect, but it's better to work on the efficiency of this. So, and I will just finish now to tell you that think always you have two processes, urbanization and global warming. Different, of course. With the CO2 coming from the urbanization is coming from the global warming. So we need to differ. So what I have in urbanization? I have urban heat island. I have modified precipitation and urban water cycle. I showed you this in the previous lecture. I will modify ecology and biogeochemical cycle. Global warming, what global warming will add to me? It will increase the intensity and duration of heat waves. It will change the precipitation and evaporation pattern. I just showed you. It will change also the hydrometeorological change, will impact ecology and biogeochemical change. So another question, how will this impact interact? So how urban heat islands interact during heat waves? Because heat wave is not due to city. Heat wave is not urban effect. Heat wave is a climate effect. So how the heat wave interact with urban heat island? Maybe it will increase the urban heat island. Maybe it will decrease the urban heat island. So if you look to the difference, but I told you, don't look always to the difference urban. Think to the absolute temperature of maybe during the heat wave, the temperature of the city will increase a lot. Why? Why it will okay in normal summer. So, and will there be positive or negative or no feedback? This is the feedback. Is it a feedback? Is there a feedback between these extremes and urban? Now we are working, I told you, on the impact of compound extreme on city, on urban climate. So this is a really new topic of research. We are working on this in Belgium to try to see, to take into account this interaction. And I think it's finished. Thank you so much.
With this, we would break for tea and come back after.